In order to develop all aspects of the design and structural strengthening interventions specific to the seismic safety of buildings, engineers at Kerakoll Green Lab Research Center, along with the engineering department of the University of Roma Tre and the Enea Research Center, have developed a set of sophisticated experimental laboratory tests, subjecting a full-scale tough masonry structure to tests performed on a shaking table and recording its dynamic behavior under seismic action. The specimen subjected to the test is designed to simulate the actual conditions of historic masonry structures, where the overturning and collapse of the facade to be found to be the most recurrent damages. The specimen, initially subjected to a test session without any strengthening, is then led to collapse when shocks are performed at increasing intensity. The ultimate limit state threshold is thus determined with a PGA acceleration of 0.3 g. The damaged structure was subsequently retrofitted and strengthened by applying Kerakoll strengthening systems consisting of Geosteel 600 steel fiber sheets applied with Geocalce F Antisismico mineral mortar. To test the effectiveness of the strengthening, the specimen is subjected to over 50 dynamic tests on a shaking table that replicate the most recent and devastating earthquakes registered in Italy, including those registered in L'Aquila in 2009 and in Emilia in 2012. Shocks were performed progressively, increasing amplification factors from 0.5 to 2.5 in order to reach the collapse point of the structure and record the mechanical limitations of the reinforcement. The sample broke down only when the Nocera Umbria earthquake conditions were replicated. Intensity was increased by 250% compared to the original recording, and with a 1.5 g base peak ground acceleration (PGA). Despite the damage to the specimen, the test is to be considered passed. The strengthened structure has indeed withstood, and no ruinous collapses occurred despite a devastating earthquake. About 5 times the expected maximum seismic action required by current technical standards for building designs in seismic areas. This experimental campaign shows that Kerakoll consolidation and structural strengthening systems, if adequately designed, considerably reduce the seismic vulnerability of buildings, improving the safety of inhabitants and safeguarding the building heritage.